Hi guys, we're going to do the next chapter 8 video here. 8.2 is the section we're in. And today's essential question is, how do you tell if a parabola opens up or opens down? So how do you tell if a parabola opens up or opens down? And we're going to get into that real quickly here, but we're going to do a little review first. In the previous videos, we've been learning how to graph quadratics. We've learned what a parabola is, that smooth, like U-shaped curve. And before we can figure out if it points up or down, we need to do a little bit of review. So over on the side over here, I'm going to write review. And just kind of want to go over a couple of basics here, starting with order of operations. So order of operations is something you learn usually as a 5th and 6th grader. And the way order of operations works is we remember that a little saying PEMDAS, and people come up with all sorts of different sayings for this. You might have heard of "please excuse my dear Aunt Sally," or some people just call it PEMDAS, but all it means is parentheses, exponents, multiplication, division, addition, and subtraction. That's what it stands for, and it's the order in which we do our evaluations of different expressions. So here is a quick review. If I told you to evaluate, and I said, let's evaluate negative 4x squared if x equals negative 3. Order of operations is going to be kind of crucial in a problem like this. And the reason for that, the reason I'm saying that is because you're going to replace the x squared with a blank, but you're still going to have everything on the outside. So if it's negative 4x squared, it's going to be negative 4 blank squared. And inside that blank, we're evaluating negative 3. So we're going to be putting a negative 3. So order of operations says exponents and parentheses first. So we need to focus on this negative 3 squared. And a negative 3 times another negative 3 is a positive 9. So we get this positive 9, but we're still taking the 9 and times it by negative 4. So negative 4 times 9, well 4 times 9 is 36, but it'd be negative 36. And now we've evaluated. And I'm just reviewing this because when we're making our tables for parabolas, we often find order of operations is kind of crucial. Knowing where to put the negative sign and kind of how to go in that order is pretty important to what we've been up to. So keeping that in mind, I'm going to switch pages here so I have a little more room. We're going to review one more thing before we start diving into the plan for today, and that is we should know what standard form is now. So for quadratics, we have what's called standard form. And this is just how we write our equations. And we know that our standard form that we typically work with for quadratics is y equals ax squared plus bx plus c. And we saw this in a previous video. Now the ABCs are numbers. So a right here is a number, b right here is a number, and c is a number. And it could be any number, really. It depends on what the equation is. It could be 3x squared or 10x squared or negative 2x squared plus 7x plus 5 or whatever. But the whole entire reason we know this is called a quadratic equation is because its highest power is an x squared. And I'm just going to note that here. So if the highest power happens to land at an x squared, that's what makes this quadratic. And that's kind of how we know, oh, it's going to be one of those parabola graphs. It's going to be in that U-shaped form. The question is will it point up like this, or will it point down like this? And that's kind of our question of the day today. How could we figure out ahead of time before we do any work which direction it's pointing up? And we're going to figure that out with some examples. So let's try a problem. Alright guys, so we are going to graph two equations for our notes today to compare them, and they're going to be kind of some interesting ones. So the first one, in fact, to kind of give myself some room here, is I'm going to work at the top. So I'm going to write y equals 3x squared. That's going to be my first quadratic that I graph today. And the other one I'm going to graph is y equals, I'm going to go for a little more complicated one, negative 3 halves x squared. And we're going to compare these two to see what's the difference between them. So I'm actually going to basically build myself a giant T-chart so that we can compare the difference between these two graphs. And what I want to do is grab a ruler. I think I want to get this all set up pretty nice and neat. And I'm going to draw on both sides kind of a matching XY axis. So I'm going to just set up the basics. Here's my Y axis. That'll be good. Hopefully this will give me enough space to work. Here's my X axis. I'll put a little scale on here. Get myself kind of organized. And then I'll do the exact same thing on the right side. I just want these two graphs kind of ready to go so that we can compare them. I don't think I'll put any numbers on my graph yet. I think I'm going to leave it blank just to make sure I'm happy with my table numbers because I don't know what those are going to turn out to be yet. So there's my setup. Okay, so we got two graphs. We'll definitely, if you need to pause the video, go for it. But I'm going to move kind of into our 3 steps of solving. So step 1 is we need to find the vertex. So down below down here, for each of these, we're going to be finding the vertex. So step 1, where's the line of symmetry really, is what I'm going to identify. And I'm going to do that for both equations, both graphs. So step 1, vertex. Now to do this, remember the shortcut strategy here is to use a formula. To find it, we just use x equals negative b over 2a. That's our equation. So really, it's going to be negative blank over 2 times blank. Except we haven't identified what ABCs are yet. So we're going to need to do that. So I'm going to go back up and look at this problem. Standard form is always ax squared plus bx plus c. Well, I definitely see the a. A is 3. But I don't see the b and the c. That's because they are zeros. 0x plus 0. There's nothing there. So the b and the c are 0. And if you look at the other equation, it's the same story. Ax squared plus bx plus c. There is no bx plus c. It's 0x plus 0. Now the a is there. It's negative 3 halves. We do have a's. We have a equals 3 and a equals negative 3 halves, but we don't have b's and c's. So when I go to do my equation down here, negative b over 2a, negative b is going to be negative 0 over 2 times a is 3. But 0 divided by anything is going to be 0. So our vertex is happening at 0. And that kind of makes me happy. It means that on my graph up here, right down the center where 0 is also my line of symmetry. So I'm going to put it right there. And if you look, if we did the same thing for the other equation, x is going to equal negative b over 2a. We're going to do negative blank over 2 times blank. Remember what the ABCs for this one